Hi everyone and welcome into this video in which I continue my Windows Privilege Escalation series. In this video we will discuss different ways of bypassing the user account control mechanism, also known as UAC. So we will see different ways of doing UAC bypasses. As always, I will use some theory. I will introduce the main theoretical and conceptual idea behind the bypasses and behind the feature itself, and then I will show it in practice within a Windows virtual machine. So, I hope you get something out of this video. If you do, leave some feedback, positive or negative, share it with like-minded people to help me grow here on YouTube, and that's it. Please enjoy the video. So, let's begin. What is user account control? Now, I had mentioned this feature in one of my first videos of the series. Specifically, it was the second one, in which I discussed the most important Windows permission systems and Windows security features. In particular, in that video, I discussed about UAC and MIC, which is mandatory integrity control. So let's review this concept and let's understand what is the relationship between UAC and MIC. So specifically, UAC is a feature that helps manage when and how applications run with elevated privileges. It requires user to explicitly authorize or authenticate before a process can gain elevated permissions. So what's the idea here? Well, the idea is that when a process has to increase its privileges because it wants to do a more privileged action, it will require the user for permission, and this is the UAC mechanism. So applications are started with the least privileges needed. So we can say if this is the lifetime of the process, we start here. So the process starts here, which is a non-privilege, like a low privilege, so like low privilege, and then maybe sometimes we want to increase our level of privileges to go into high privileges. Now, when we do this increase of privileges, in this there is a security boundary that we must be careful on how we deal with it. Because when a process increases its level of privileges, if then it gets attacked right here, the attacker will have compromised a high privilege process, which can be dangerous. So we want to be careful and we want to make sure that we only do this if we really want to do some high privilege action in a way. And in this picture, UAC is the feature, is the security feature which deals with how this boundary is handled. Like how does it happen that a process from low privileges goes into high privileges? When an application requests higher privileges, a prompt is used to ask for confirmation, and this prompt is the UAC security feature mechanism. Now, UAC is a security feature that can have different configuration levels. So we can go from less secure to more secure. We have different sort of this kind of prompt, this consent is asked in different ways, and it requires different kind of information to be properly authenticated. So for example, the level 0 means no prompt. It means that when a process goes from low privileges to high privileges, nothing is asked of the user. In this case, the bypass is pretty trivial because there's nothing to bypass. UAC is simply not configured. Then we have different levels, so we can have a prompt for credential on secure desktop or prompt for consent on secure desktop. Now, in both of these prompts, we are talking about this concept of secure desktop, which is sort of like a level of isolation from all the other running applications. And this is made so that malicious software that runs on a machine cannot interfere with the UAC prompt. So this prompt does not happen in any process of the system, but in isolated processes, so there's more protection. Now the first level asks for credentials. It means it's going to ask for the password of the user, while the second asks for consent. Clearly, the one is stronger in terms of authentication because you're not only saying, okay, you can gain higher privileges, you also have to authenticate as a user to the machine. You have to put the right credential for the user. So it is stronger. It requires more information. But both of these are on the secure desktop. Then we have also credential and consent, but for the normal desktop. And in the normal desktop, it allows other programs and windows to remain active and interact with the user while the UAC prompt is on screen. So it provides less isolations. And finally, we have the fifth level, which is prompt for consent for non-Windows binaries. So when we are executing a binary that is not native Windows, which means a third-party library that is not signed by Microsoft, then for those, we will prompt for the user consent. So we have different levels of configuration, and in this video, we will see exactly how they work and why they are different and things of the sort. And so this is the idea of UAC. It is a prompt, it is a security boundary that happens when a process goes from low privileges to higher privileges. So it's low, it wants to increase its set of privileges, and here UAC, depending on how it's configured, it can ask for more or less confirmation in a more or less isolated environment. Now, another thing that relates to UAC is mandatory integrity control. And here the idea is that we have different integrity level from low, medium, high to system, where low is the lowest privileges, so like not many privileges, medium is a little bit higher, higher is also higher, and system is like the highest of them all. And essentially MIC enforces restrictions by preventing lower integrity processes from writing or modifying higher integrity objects. So the idea here is that even though I am an admin user, if I start a process with a medium integrity level, then I cannot do certain actions, I cannot modify certain objects which require a higher integrity level. Even though my user can technically spawn processes with high or system integrity level, I actually don't want to do that, because to respect the least privilege design, the least privilege, what's the idea? Well, the idea is that I only want the privileges that I strictly need to perform the action that I want to perform. If I am an admin, this means essentially that if I am an admin, but I just want to create a simple file in a directory which does not really require me to have higher integrity level, then I can just spawn a shell with a medium integrity level and just be fine with that, because I don't need higher integrity levels. Then, when I actually need higher integrity levels, I can ask for more, I can increase my integrity level, and at this point, UAC comes in. So the concept, the abstract concept that we were talking about increasing the level of privileges, comes back to MIC, to the integrity level defined in MIC, which can be either low, medium, high, or system. For example, if I am a shell running at medium and suddenly I want to increase it to high, this is a security boundary which can be protected with UAC. So that's essentially the idea. And indeed, what's the relationship between UAC and MIC? MIC and UAC work together to restrict unauthorized access and manage privilege escalation problems. MIC provides the underlying enforcement mechanism for integrity levels. So essentially it is the access control mechanism that Windows uses to handle privileges and authorizations essentially, while UAC provides the user interfaces and the mechanism for increasing those privileges if it is required. So when a standard application attempts to perform an action that requires elevated privileges, UAC triggers a prompt. Then, if the user consents or if the user authenticates, depending on the UAC configuration, the process integrity level is elevated from medium to high, for example, or from high to system. So to recap, MIC enforces a policy-based boundary based on integrity level, while UAC controls how and when processes can cross those boundaries. So that's the idea. Now let's go into practice, because this was a lot of theory. It can be boring, but the important part is, okay, let's see how this concept play out in real Windows system. So let's say that you have a real Windows system, you have a shell on it, and you want to understand how UAC is configured and how maybe you can bypass it. So let's first enumerate the UAC configuration. How do we do that? Well, we can actually read some registry entries. For example, this one this HKLM software Microsoft Windows current version policies and system, and from this we're gonna select the object enable LUA. So this is gonna tell us if UAC is enabled. Specifically, if it is enabled, we will get a 1. And to read this value from the registry, as always, you can use either PowerShell with the get item property, or you can use the cmd.exe with the reg query command. For example, let's do this first, get item property. We will need PowerShell. Here we have it. We're just gonna do this, and look at this, we have enable Lua 1. So we have it enabled. If we open a shell, command prompt, then we can just do reg query, essentially this one. And here we get reg dword 0x1, which means it is enabled. So all good. So this is the first step. Is it enabled or not? The second step is, of course, okay, what kind of configuration level do we have? Because remember, it's not like UAC is just a binary setting. Either it's enabled or it's not. It actually goes into 6 different levels, from 0 to 5, where 0 is no prompt and 5 is prompt for consent for non-Windows binaries. So how do we enumerate the specific level? A different registry item. And so to read the specific configuration level, we can read another registry entry. Specifically, we have to read the consent prompt behavior admin, which we can read with this simple PowerShell command. So get item property, this is the registry key, and this is the value that we want to extract from that registry entry. So we do this, not in the cmd.exe, of course, but in the PowerShell. And notice that we get this level 4. Now, level 4, we go back to this, means prompt for consent on the normal desktop. So we will see essentially what this means. So we have this value. Let's say though that we want to set a new UAC level. How can we do it? Well, for example, we can use the cmd.exe syntax to change the registry entry. Essentially, we can do reg add. We put the policy system entry here. Then we put the value that we want to change, and we put the new D. In this /D, we put true. For example, in this case, it's gonna change it to true. Of course, to do this action, we need to have certain privileges. If we just do it on this shell, look at this, it's gonna say access is denied. Now, why does it say that access is denied? Because the interesting thing here is that if I check my groups, the groups I belong to, which is the user quick emu, if I say, for example, who am I, okay, this one is who am I, but if I say who am I /groups, it says, look, technically I am in the administrator group here, built-in administrators. But in this specific process, I'm actually running with a medium mandatory level. So in the MIC integrity levels, this is just a medium shell. It means that it is limited. I cannot simply get access to the entire system, not because my user does not have access to those, but because the process that the user spawned, which in this case is the PowerShell, has medium integrity level. So here, there's just a big thing to understand is that one thing is the privileges of the user, which in my case, for example, this quick emu has the built-in administrator group. So it is a privileged user because it belongs to a privileged groups, but this thing is not necessarily the user privileges are not the same as the process privileges. And when I interact with a system, for example, let's say that I have a reverse shell that I obtain in a system, I'm dealing with a process, and the process integrity level might be different, might be lower than what it can actually be. So the point now is, okay, how do I increase it? How do I go from medium to high? Well, going from medium to high requires elevating privileges, therefore requires bypassing an UAC prompt. I mean, in a way, I have to pass a UAC prompt, and if I'm a malicious actor, I have to bypass it. I have to find ways of bypassing the prompt. So this is the basic idea. And we will see in this video ways in which I can go from medium to high, which is a typical vector for privilege escalation. So at this point, we can start to talk about UAC bypasses, which is clearly the most interesting part of the video, which is the point of this video. However, before talking about that actually, let's see in practice the various levels at play. Because it is really important to have a clear understanding of the feature we want to bypass before we actually bypass it. So how can we get this clear picture? Well, the idea is that we're gonna start from the no prompt level, and we're gonna go up to the 5th level, to the prompt for consent for non-Windows binaries, step by step. And to do this, here we actually get this command, this start process, and actually we're just gonna modify it a little bit because this start process is gonna be used to increase the level of integrity. And specifically here we have the file path that we want to execute. In the future, I'm going to execute an endcat, but for now, I'm just going to execute a PowerShell instance, so very simple, PowerShell.exe. I'm going to remove the argument list because I don't need it. I'm going to remove this Windows style hidden because I don't need it. And then I'm going to keep this dash verb run as. Now this run as is going to try to increase the integrity level. It means increase the integrity level, and depending on the UAC configuration, we will see different behaviors. So we take note of this command, and then we take note of the command to change the UAC levels like this. So let's start from UAC level 0. So here I go I need an administrator prompt. So I need an administrator prompt here. It's going to execute this as administrator. And notice that it tried to ask me for the UAC prompt. What we saw was a UAC prompt, but we will see them better and more slowly, so don't worry. So let's start with level 0. So this is level 0. I just modified the UAC prompt to be level 0. Let's see what happens when I do this. So notice here, I am a mandatory medium integrity level. And if I check my privileges, there are not that many here. But I can do start process, file path, PowerShell, verb run as. I get a new PowerShell. And notice this. I say UMI groups. And I'm high mandatory level. And if I do UMI priv, I have way more privileges, because now the integrity level of this process is no longer medium, it is high. So it's much stronger, clearly. And notice that in the increase of privileges of integrity level here, I go from medium to high, no UAC prompt has appeared because it is not configured to appear. So this is the level 0 essentially. If we have level 1 instead, notice what happens. I do this, and now I get this UAC prompt. I get it on the secure desktop because nothing that I cannot interact with other application. So there is a level of isolation between this process, the process responsible for this window and for this password, essentially for getting this password, and all the other processes of the system. Here I have to put the password of my user, and then when I'm gonna put it, I press yes, and the process is gonna spawn. So for example, here I have the password, I press yes, and now it spawns the process. So this is UAC with level 1 essentially. I say UMI groups. Once again, I have a high mandatory level. I have a high integrity level. So let's go number 2. Let's do this. Notice now that it does not longer ask for credentials, it asks for consent, but it asks for consent in the secure desktop once again, because it's isolated from all the other application. I say yes, and it spawns a shell. And here I have essentially once again the high integrity levels. I'm just showing it for transparency, we can say. Then we increase it to 3. 3 is gonna change because 3 now, look at this. It asks me once again for the password, but I am no longer in the secure desktop because look, I can interact with other processes, so there's no longer isolation. So this is the difference, the practical difference between here secure desktop and normal desktop. You can see it clearly here, right? And so once again, here I have to put my password, and then it's gonna spawn a shell with higher privileges. Not gonna put a password because we already understand this. Then we put 4, and notice here, it's gonna ask me for consent. Consent on the normal desktop. I say yes, and I have a shell with higher integrity levels. So that's essentially the idea. Here is coming down stack a bit. It's loading, perfect. Then I put level 5. I start PowerShell, and it asks me, essentially, do you want to allow this app to make changes to your device? So it still asks me for consent, essentially. Show more details, verify, publish, and Microsoft Windows. So even in this level 5, it actually asks me for stuff, I don't know why, maybe PowerShell is considered a non-Windows binaries. I'm not sure exactly on this level 5, but that's the idea essentially. So as you go up, you get more wide with respect to how many things you ask the prompt essentially. So this was just a quick enumeration, a quick viewing of the different UAC levels. And finally, now we can actually discuss proper bypasses. So in this video specifically, I'm gonna show 3 different bypasses. The first one is super easy because it's at level 0, so there's technically no bypass. The second is on level 5 and it uses the fodhelper.exe, which is a Windows binary, which is like internal, a Windows binary. And then we have level 1, 2, 3, and 4, which can be bypassed using a different technique, which has to do with always install elevated configuration, which I'm actually gonna talk more thoroughly in a future video. In this video, we will just use this, we will just see this technique in action to bypass the UAC prompt essentially. That's the idea. It is also worth to mention that like a lot of UAC bypasses have to do with DLL hijacking, and I've made a full video about that technique, which involves introducing malicious code as a DLL and then either overwriting original DLLs with malicious one or tricking the Windows search order to find the malicious DLL before the original ones. So it's a common technique used to, you take a program that immediately starts out with higher integrity levels, and then you do DLL hijacking on that specific process and you get higher integrity levels without going through the UAC prompt. That's the key idea. So let's start with level 0. Level 0 is super easy because once again we just use the start process, we just say run as, and this is going to increase the integrity level. Since there's no UAC prompt, we can just bypass it because essentially there's nothing to bypass. I mean, it's very, very simple. So here we put integrity level 0. Here I'm going to put a listener to the port of 4321, and then I'm going to execute this command. So consider this scenario. I obtain a reverse shell. I am inside the system, but I do not have full access to the privileges of the user because I am running with a medium integrity level. And I can check that with /groups. This is medium mandatory level. It's not good. I want high. I want higher. So what do? Well, I check the UAC. I go like, okay, wait a second. Let me enumerate the UAC level. So let me do this get item property, whatever, here. Okay, look, it's 0. It means I can easily bypass it. Perfect, I just do this. I just do start process with a netcat with a reverse shell command essentially. And let's just do it from the middle integrity level. And look at this, I have a shell. And not only I have a shell, but I have a high mandatory level shell. And in this shell, I have all the privilege that I can access. I can get full access to the fact that I belong to the administrator group. So that's essentially the idea. So this is the first bypass. As I said, pretty simple because there's actually no bypass. And so the level 0, as I said, was pretty easy. Now let's go into a more interesting level, which is level 5. Let's say that I have a level 5 UAC configured. Now in this case, if I try to start the previous command here, it's gonna ask me for this prompt on the graphical interface. And so it's not easy to bypass it from the PowerShell command line. So how do we overcome this? How do we bypass this consent? So that's the idea. Well, the idea is to use this fodhelper.exe. Why do we want to use this utility? Because this is actually a Microsoft utility. It is a program found in the system and is signed by Microsoft. And how can we check that it is signed by Microsoft? We can use this sigcheck.exe, which is a sysinternal utility that you can download here, sigcheck in learn.microsoft sysinternal, so you can just download it essentially. So how do we use it? Well, you just do sigcheck.exe, then you put some flags, you point to the fodhelper.exe, and look what you get. Essentially, you get a bunch of data, and you get a bunch of XML, and in this XML, it says auto-elevate true. So essentially, that's the idea. It's going to auto-elevate the integrity level without requiring a UAC prompt. So specifically, how does this bypass work? Well, we can use this Windows utility with this FOD, which stands for Features on Demand, to bypass the UAC prompt. Now, specifically, Windows treats the fodhelper.exe as a trusted system application, which means that it runs it with high integrity without triggering a UAC prompt. Now, this specific attack works in two steps. In the first step, the attacker modifies a registry value in order to configure the malicious command that will be run with higher integrity level. And then in the second step, the FOD helper binary is executed. So the setup of the attack involves modifying the registry, but in a way that we have access to it. So the normal user has access to it. So what do we do? In practice, first we create the registry item with the command new item at the path hkcu software classes ms settings shell open command with the dash force flag. So we just do it here in the medium integrity level, and it says, look, I open this thing, and then we can configure it with the malicious values to execute a cmd.exe. So specifically, here we have name default, and value here is the command. So the command is in the value of the key default, and then the delegate execute has to be empty. So we add two item properties. One is the default in parentheses, which contains the malicious command. The other is the delegate execute, which has to be empty. So for example, if we want to execute a reverse shell, we can just put in the value here the typical command for a reverse shell here, set a property. Then we put the second value empty. And finally, we just execute the FOD helper binary. So we do FOD helper.exe. Notice what happened here. We got a shell, and this shell runs with higher privileges because this shell runs with higher mandatory level. So we did not see any UAC prompt because FOD helper starts as a higher integrity level process. It does not pass a boundary. And when it passes a boundary, it's signed by Microsoft, so it does not trigger the UAC prompt regardless. So there's no UAC prompt, and we still got a high mandatory level shell. So this is a typical way in which this can be done. And so to recap this bypass level 5 of UAC, we use fodhelper.exe. Now, does this bypass also work for other levels? Well, let's try it out. Let's put, for example, level 4. Which should ask for consent on the normal desktop. And let's just do this thing once again. So let's just call here from the low here, we call FOD helper. Notice that it asks for UAC prompt. So it does not work for level 4, it does not for level 3, 2, or 1. So it works for level 5, because if we put here 5, it's not gonna ask us a prompt. Look at this 5 here, but we execute this. No prompt, we get execution. Very good, very good. But it doesn't work for level 4, 3, 2, or 1, clearly. So how do we do that? Well, if we have, for example, let's say we have level 1. Level 1 is the hardest, right? Because level 1 we have password in the secure desktop. Wow, how do we even bypass that, right? Well, in this case, there are other ways. So the idea is that you find a process that runs with higher integrity levels, and you try to hook into that. You try to sort of introduce malicious code into that. For example, one way is to use the always install elevated configuration, which is a configuration that if enabled, it runs like MSI packages, so installation packages with higher integrity levels, also with the integrity level of system, so that's the highest. And this also will allow to bypass any UAC levels, essentially. So here I have a small demo. I will not discuss fully this thing because I've prepared a full video on this, but how does it work? Well, let's say that in our machine, we have a malicious package, this sample2.msi. So essentially the idea is that let's put a listener to port 777, and let's install it with this command, msi exec/quiet/qn. I have to go a bit better, so I'm gonna do this, Notice what happens. I get a shell, and notice even more, if I do groups here, this shell has a system mandatory level, which is the highest integrity level. Now, why was I able to do that? Because this is a malicious package, and the system is poorly configured with this always install elevated configuration in the registry, which allows me to obtain this kind of integrity level when installing new packages. So that's the idea. If you want to know more about this, you just have to wait for the next video, because I've already prepared it. I'm gonna record in a bit, where I discuss about always install with elevated privileges escalation. So the escalation using this always install with elevated privileges configuration. So that's the idea, and in this video, in the future video, we will see how to create a custom MSI and how to exploit and how to do configuration check, you know, the usual thing essentially. So this is it for this video. Here are some references, but I hope it was interesting. I hope it was a fun experience. I hope it made you understand what is the point of UAC, how we can bypass it. Of course, I did not show all the different ways in which you can bypass it, because it's not like there is an exhaustive list of such ways. As I said, most of the times it happens with DLL hijacking on specific binaries that run with higher integrity levels. However, the general idea, the intuition that I want you to build on this topic is UAC happens when a user goes from lower integrity levels to higher integrity levels. So the idea to bypass it is to start from a higher integrity level or to use specific systems that start with higher integrity levels, such as the FODHelper.exe. We can bypass it with FODHelper because at level 5, FODHelper, since it's a Windows like trusted binary, it does not ask for UAC prompt because in level 5, UAC prompt is asked only for non-Windows binaries. So for a subset of all the binaries in the system, and in level 5, FODHelper is not one of those, so it bypasses the UAC prompt by its own nature in a way. So that's the idea for the UAC bypass. So this is it for this video. I hope it was fun. Share this video with like-minded people. Subscribe to the channel to help me grow and to motivate to make even more videos like this. And to the next video.